you ready?
I'm already videoing.
Okay, excellent. Hi. You better say hi to my other classes, right? Ha ha. You guys are go on your own. Okay, so what we're going to do is we're going to use the ideal gas law to determine the molar mass of the aerosol compound in this dust blaster. Everyone's like, what are you going to do? Okay, so we got to collect some data to do this because we know that there are 4 variables: pressure, volume, temperature, and number of moles. So what we're going to do is we're going to actually calculate the number of moles of gas, but we're also going to figure out how many grams of gas we're releasing. And by doing that, we can figure out the ratio of grams to moles, which is the molar mass. Okay? All right. So first thing we need to do is we need the mass of our can. Okay, you're closest. So just shout it out to us. I hope it will be measured. We can measure it. I'll edit this video.
316.89.
Yay.
Okay.
18.89. You're gonna be watching it tomorrow.
316.
I love you, roommate.
Okay, now the way this is going to work is we're going to track the gas. So I've got to fill this up with water, and then we're going to collect the gas underwater.
I can see all of
Davis.
You can stop it, and then, oh no, look what happened.
What?
Do you see that? I got an air bubble.
Oh no. Darn it.
No.
Bubbles are bad.
This is also a what do you call it?
Isn't that really, really hard to
Yeah. This is why, this is the skill part. You're going to do this next week in your final lab.
Oh.
Okay. Now, we're not going to obsess too much about the air bubble. It's smaller now. Okay. So, we're going to use water displacement to collect our gas. And guess what? We've got a graduated cylinder, so we can measure the gas correctly. Stick it in there. Oh, while Julia's doing the temperature, could somebody do a Google search for the atmospheric pressure today? So somebody go on a weather.com or another website and let's find the pressure. What is?
No, it's been on different
He's gonna be so embarrassed.
Well, maybe it's the same temperature as the air. So the temperature of the water is 20.7. And because the water and the gas are going to be in contact to each other, that's also going to be at the temperature of our
Celsius.
Did
Yeah, it says
Celsius. Let's see if it's the same for Pomfret, Connecticut.
I don't think they know what Pomfret Connecticut is. They just guess.
Okay, but it says like in the top corner.
There actually is a weather channel for it.
30.3.
It's 30.3.
Oh, we're way
Yeah,
off.
30.3.
Okay.
So
Do you want me to move it down?
30.3.
I really think actually do.
30.30.
Pomfret is, and then just
All right.
random weather.
So now here's the big tricky. This is the hard part. Is I'm going to take the dust blaster and I'm going to put the gas into the graduated cylinder until we have about 250. So just make sure I don't go over the mark. Okay, ready? Here we go. Look at that. There it comes.
Whoa. Whoa.
This is what we call very years of experience right here.
Oh, this is what you do underwater when you do like blow, blow, blow.
It's tilted a little bit. So.
No, it's still going. Okay. I think we'll just stop there and not push my luck. All right. So we have our gas. Now we got to measure the volume. My eyesight isn't excellent. Okay, there we go. Now we're about even. Can you read that, MK?
Should I like
Counting from the down.
2? That's
So here's-
220?
There's 190. That's 210.
No, no.
Hi, Julie.
It's almost 17.5.
Okay. Final mass of our can.
316.10.
Did it go down?
Yeah, no. Not
Yeah,
a lot,
it
though.
It should have gone down.
No, a
It
lot.
went down like
That's our
0.7.
biggest source of error right there is the mass because I don't have a balance that measures to the hundredths less. Okay, so a couple of things before we start calculating. In here we have 2 gases actually. Do you know what else is in there besides the aerosol?
Oh, dude.
Oh, subtracted.
Oxygen.
No.
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 H2O.
Yes. Water vapor. Anytime you have a gas trapped over water, there's water vapor in there, and the amount of pressure from the water vapor can be looked up on a chart. So in order to figure out the pressure of our gas by itself, we have to take the atmospheric pressure and subtract off the pressure of the water vapor. Okay? And then we have temperature. We have to change that to Kelvin. We have pressure. Well, we should probably, you all need to decide what pressure unit you want to use. You can keep it in inches of mercury if you want, as long as you can find the vapor pressure of water in that same unit. But then you have to use the value of R that matches it. Okay? And then we're going to work through the calculations. Okay, that's it. Let's see if our temperature changed. The pressure's the same, so you can go ahead and fill that in.
Don't you mean the temp?
The pressure, the barometric pressure should be the same.
Swim.
It's
There's no storm that went through or anything, right? Since we last did it. Oh, the temperature went up to 20.8.
So it's 293.8.
On the website, was it inch mercury or?
Yeah.
It was an inch.
Oh no. Oh no. Source of error. Because if it goes over, then we can't measure it, right? Yeah. Kia? MK, you ready? Get your reading glasses on.
Oh, a source of error.
Did you see that? I have that there. See the
This doesn't seem right.
what?
315.08.
That's right. That seems
Yeah.
perfectly right.
315 what?
0.08.
Did it go down again?
Yeah.
Why? Went
Yeah.
down like
True.
a gram.
So now we're over.
You're gonna spill it over.
It's okay. I've got the spillover beakers in place.
Bird's eye view.
I keep
We're right at 240, don't you?
But we're like,
Right on
it's
the
not
top.
on the
Was
level.
I in that?
Is it above or below?
Oh, this one is above
Can I just
that.
use this for my keyboard real quick?
Yeah.
There you go.
All right, we're 241.
242.
Well, what's that mark? 242. Yeah. Dot. 242 dots. So it's got the.
Should the 217 from before have a dot of decimal too?
217. No, it's 3 significant digits. Now watch what happens here. This is what happens when you change
Yeah, hold on.
the volume. Now watch what happens to the water level. We're right about 240, but when I lift it up, it goes under the mark, but when I push it down under the water, it sounds like it's going to the bathroom, but it also goes down lower. So
Isn't it like
the reason why we measure it right here is because that's the point where the pressure inside is equal to the pressure outside. So if we put it down below, we're altering the pressure a little bit, so it's changing the volume. And if we pull it out, and when we do this in our final lab, you're going to have a large graduated cylinder, and you're going to have to do that step too before you measure your volume.
Wait, our final lab, we're doing
She's
it.
behind you guys.
You're not doing exactly this, but you're going to use the same technique
she
to
did.
collect gas.
Water
Okay.
fell onto my keyboard.
Thank you. We're done.
That sucks.
We are
Can I borrow
done.
that
Let's
too?
do some calculations.